Hello everyone. Today we learn about MCB. Generally we use MCB in each and every electrical circuitries, but we also know about how it's work and what is the mechanism it has and all that, but many times we fail to select correct MCB ratings or correct MCB types for our application. This is the main reason behind making this video. So in this video we will discuss how to select MCB, what are the types of MCBs, and for what application and what type of application, what specifications you have choose for the MCB. Type wise, if we generally think about MCB, it has a 4 general type. We can see over here that it is a single pole, dual pole, 3 pole and 4 pole. According to our application, we can select MCB in single phase. We can go for single phase or dual pole. Likewise, for 3 phase application, we can go for 3 pole or 4 pole MCB over there. We are not going here for a detailed specification like B type, C type, D type, K type, Z type. We will discuss these all things later. Here you can see that internal structure of MCB. You will find many video about how MCB works, what is bimetallic plates, what is cylinder, how it will operate during that overcurrent operation or short circuit, but a very few videos or no videos about how to select correct MCB for your applications and what should you know about MCB before selecting it for your application. So I am making this video. Let's go for selection of MCB. To select correct MCB, we have to select current ratings of MCB. Here this simple formula we use to select correct MCB. I is equal to P divided by V. P is power. Generally P is given with all our load like fan, tube lights, LEDs, whatever the load we are using. It gives that what's wattage capacity it has. So we can get that P from there. And V is standard for Indian condition. Single phase it is 230 watt. This is our that line voltage, and whenever this 3 phase calculation is that we will get that voltage for line to line voltage. It is 415 volt. To select the specification of MCB, let's have one example. Let's see, we have 90 watt fan 4 numbers, 125 watt TV sets, 40 watt tube lights in 4 numbers, 400 watt refrigerator, and 1.5 ton AC which consumes almost 2600 watt. To get a power, this P, we have to add this all quantities, this watt. After addition, we will get its total power consumption of our circuits. It is 3645 watt. We will put this in our equation. It is I is equal to P divided by V. Here we know now P is 3645 watt and our standard line voltage is 230 watt. Here it is 230 watt. Okay, so when we divide this 3645 watt, we will get 15.84 ampere. It will come into ampere. So approximately we require in this case is 16 ampere MCB. Here we are use this calculation for single phase. Let's see over here example for 3 phase circuits. Let's have a 5 HP motor. If we convert 5 HP into kilowatt, then it will be 4.8 kilowatt. We will use I is equal to P divided by under root 3 VI cos phi equation over here to calculate our current. 4.8 kilowatt equal to 4800 watt. We will divide it by under root 3, which has 1.73 into 415 watt. This is the 3-phase phase to phase voltage, and 0.9 is our power factor. We know what is power factor and what is significant of power factor in our circuits. When we calculate this whole value, it will be 7.42, and here we can use that at ampere MCB of 3 pole. We have to say here 8 ampere 3 pole or 4 pole MCB. We can use 3 pole or 4 pole MCB for this. You can see that here that our load for single phase is 3645 watt, here 4800 watt. That load is higher, but MCB rating is decreased because all your current will be divided in 3 equivalent phase, equivalent current carrying capacity phase. So this rating is decreased. This all fundamentals, I hope you have very much clarity about this all things. Now we know how to calculate the current capacity of MCB, how we can calculate that current what our circuit carrying, and according to which we can select our MCB. Now we can further divide our MCB in 5 types, that is B type, C type, D type, K type and Z type. This MCB bifurcation on base of its full load current capacity and operating times. B type MCB, that tripping current time is 0 to 4 to 13 seconds, and it can carry 3 to 4 times of full load current than its specifications. Means you can have idea that if your MCB is of 16 ampere, it has full load current capacity of approximately 3 times, means 16 into 3, it is 48 ampere for 0.4 to 13 seconds. If more than that current lies in the circuits, that MCB will be tripped. Same like C type, D type, K type and Z type MCB. Here for this type we have much important to select our MCB, because for our some that inductive load or surge load like motors and all that, this goes up to twice or thrice or sometimes 5 times at the time of starting that equipment. So wisely, to avoid that sensitive tripping, we have to use this type of MCBs, that B types and C type. This type of sensitive loads we can use that B type of MCB over here. That C types we can use generally for our that home appliances, where 5 to 10 times full load current is rated, and it is for operating type up to 5 seconds. D type MCB is for very sensitive loads, but it is also avoids our that sensitive trippings, like it has some that full load current capacity 10 to 20 times of its current capacity, but it has sensitive operating time of 0.4 to 3 seconds. Here K type MCB is have more sensitivity with its full load current of 8 to 12 times, and Z type of MCB we can use for our that very sensitive load, which has 2 to 3 times of full load current capacity with 0.1 second tripping time. This Z type of MCB generally we use for our sensitive circuitries in electronics. K type MCB we have for our loads which have some that high starting currents, but it's normalized after sometimes, and it is also some type of sensitivity to avoid that short circuits and overload protection. We have that operating time is 0.1 second over here. So according to this table, you can select your MCB wisely according to your load characteristic. So when you see the MCB, you will easily find out the specification written over it. Here you can see that it is B type 32 ampere MCB. Here it is C type 16 ampere. Likewise it is D type, K type and Z type of MCB, and all over here that its specification in ampere capacity it is written. So this all are, you can see, is one pole MCB. Same way you can have a 3-pole MCB, and the specification also written over there on MCB. Here you can see that 3-pole MCB and 4-pole MCB. 3-pole MCB have a 3-phase connection and do not have protection for neutral. In 4-pole MCB you have the protection for neutral. 3-phase and neutral connection is on there on MCB. Here 2-pole MCB have phase and neutral connection, and for single pole MCB it has only connection for phase. For neutral wire you do not have any protection over for single pole. Thank you very much for watching this video. In future we will cover all the topics, all the devices related to electronics. We will also cover some renewables parts. And to have notification of all this video, please subscribe this channel and like this video. Thank you very much.